Okay, so we've learned about relations and functions briefly last week, so we're going to look at a couple of more examples here just to make sure we all really understand what we mean by a function. So this is an example of a PSSA sample item for 8th grade, and this is one of four functions that or one of four choices we're asked to decide, is it a function, yes or no? And so you may remember last week we looked at what was called the vertical line test. And that was a way of examining a given graph to see if it was a function. And the rule says that if I draw any vertical line that I can imagine, if that vertical line touches the graph more than one time, it's not a function. So there's one. There's one. Now I'm not drawing these very straight. That's a little better. And you can see I could keep doing this all day long, and no matter how many times I do it, every time the vertical line that I've drawn here crosses, it only crosses it in one place. So that means that any time I've got, if I were to list these as ordered pairs, each x coordinate is paired with only one y coordinate. So this one, the answer is yes, this is a function. How about this? Is this one a function? Well, the numbers are a little bit too big, especially the y values, to put in a coordinate plane and try the vertical line test. But you remember hopefully from last week that when we are looking to see is this a function, we want to think about the inputs. Remember, by the inputs we mean the domain. That's this stuff, the x. And the range, which is y, also called the outputs. And a function is a situation where every single input is only mapped with one output. In other words, if I look at a table like this, and I don't see these x values repeating themselves, then that means we have a function. And hopefully some of you saw that last week as you were practicing in IXL. It really just came down to identifying whether or not you saw any repeats. And we don't see any repeats, and so the answer here is yes, this is a function, most definitely. Now this one's different than either of the other two. This is an object you've probably not seen before. This is an example of a quadratic equation, something that you'll study a little bit in Algebra 1 and then quite a bit in Algebra 2. So there's two ways we can look at this. One way is to just take a calculator here and actually plug in some numbers for x and to see what we get as our y. And pretty easy to do if we pick really easy numbers, like 0 is always a really easy number to work with. 8 times 0 squared is 0. 11 times 0 is also 0. So I'd have 0 plus 0 plus 14, and that's just 14. You could pick another really easy number like 1. 1's really easy to work with. In that case, I'd have 8 times 1 squared, which is just 8, plus 11 times 1, which is just 11. And then, of course, plus 14. 14. So these added together, and it's not really easy to add them in that order, but if I add these two together first, that gives me 25, and another 8 gives me 33. So it looks like I could plug in as many numbers as I want for x, could go with 2 and so on, and the math is going to give me a unique answer each time. In other words, if x is 1, y is 33, it can't be anything else. There's no way for me to come up with a different answer. Another way to think about this is if we were to graph this. Quadratics have a graph that's shaped as what's called a parabola. And as we saw in the vertical line test in the first example, if you've got a parabola like this, you can draw as many vertical lines as you want, and they're only ever going to be able to cross the graph one time. And so graphically speaking, that's why this is a function. And so the answer to this one is yes, this one is a function. So by now you're probably thinking, well, we've had 3 choices before now, and the answer was yes. So one of these has to be no, and you would be right if your hunch told you that. This is an example of a non-function, but let's look at why. Why is this not a function? Well, I could use the vertical line test that we used in example 1 and that we mentioned briefly on the last example, and that's just this vertical line right here. I can see that if I drew that vertical line, that would definitely hit the graph in these 2 places. Those solid dots mean that those are 2 ordered pairs. So I've got the ordered pair 0, 0, for example. That's the lower one right here. But I've also got the ordered pair 0. I'm going to say that's about 2. And so if the question is, what happens when x is 0? Well, the answer is, well, there are 2 of them, right? 0 and 2. So going way back to our bread machine example from last week, if I put in 0 cups of flour, I should get 0 loaves of bread. But then maybe in the next day I turn my machine on, I don't add any flour, and I get 2 loaves of bread. Obviously this machine is more than just broken, it's haunted. Definitely not a function. Now, I will say that if one of these 2 vertical points lined up on top of each other, if one of them was open, that would mean that that part of the graph is a boundary but not an actual part of the relation. And so in that case, it would be a function. But this right here, based on this mapping, this one is not a function.